there, Mr. Holcomb here with another episode of The Math Behind the Module. This is lesson 18, determining surface area of three-dimensional figures. So the opening exercise says, part A, what three-dimensional figure does the net create? And you're probably wondering at this point, what net? I don't see a net anywhere. All right, well, in class, I handed out papers that look like this, and that is the net. So looking at this, we're now going to answer those questions. Okay, so take a look at that. It is a rectangle, and they're all rectangles, just of different sizes. So we fold those all up, we create a rectangular prism. So that's the answer. A rectangular prism. Okay, B says measure in inches and label each side of the figure. Okay, so I will do that, and I will let you know what the dimensions are from the actual printout, and I'll write them on this computer printout here. Okay, so here is a copy of that net, and I have measured everything. So everything that's red, obviously all these lines that are parallel are going to have the same length. This side's 3 3/4, this is 3 3/4, so I color coded all these. These are all 3 3/4 inches. This is the height of the box, and it's 15/16 of an inch, so therefore this would also be 15/16, and so would this. Because if this gets folded up and becomes the back side, and this gets folded up and becomes the left side, they have to be the same height for this top to sit on top. So this is 1 7/8 inches. This is 15/16, 15/16, an inch and 7/8, 3 3/4, an inch and 7/8, 15/16. All the way around, we know all the dimensions by these color codes. Okay, so now it says measure in inches and label each side of the figure. So I've kind of done that. I just use color codes to speed this up. And C says calculate the area of each face and record this value inside the corresponding rectangle. Okay, so I'm going to do it over here first, then I'll move it. So I say area equals base times height, because they're rectangles. And area equals, and I'm doing the rectangle on top first here. And the base is 3 3/4 inches. So it's 3. And I'm going to make that a mixed fraction first. So 4 times 3 is 12, plus 3 is 15/4 times 15/16. So now that I have the two dimensions, it's a fraction over, and so when we multiply fractions, the numerator times the numerator is 225. And the denominator times the denominator is 16 times 4, or 64. Okay, so now I just wanted to show you what I calculated in my calculator. So I took the 15/16 times 15/4. Okay, and that comes out to be 225 over 64. Which divides out to be 3.515. So then I took the 225 as a fraction, it did not reduce, so then I said, okay, well, if there is a remainder here, and I know that 64 times 3 is 192, and I had 225, so I have 8 to get to 200, then 25 more would be 33 as a remainder. So 64 times 3 is 192, with 33 remaining to get to 225. So it's 3 33/64. Okay, so that equals 3 33/64 of an inch squared. So I will put that label right here. So since that's true, then this is also 3 33/64 of an inch squared. So that's two sides done. Now I will do this smaller rectangle here. So I'll say area equals base times height. And my base is 15/16 times my height, which is 8 times 1 plus 7 is 15/8. So my area of this portion is 225 over 16 times 8, which is 128. Okay, so if I do 225 divided by 128, I get 1 with the remainder, and it will not reduce, so I'm going to take that remainder and see how much is left over. Well, if it's 128, then my remainder is whatever I have to get to 225, and that would be 97. So my remainder is 97. So the area is 1 and 97 over 225. Okay, so I got to think about that. It's not 197 or 225, it's 128. So it's 197 and 128. So if I move this here, this is 1 and 97 over 128. That will go there. And then also this one over here is 1 and 97 over 128. So that's those two pieces. So finally, all I have left are these larger ones. So the formula is area equals base times height. And the base is 3 3/4, which is 15 quarters, times inch and 7/8, which is 15/8. So the area is 225 over 32. Open my calculator. 225 divided by 32, and I get 7 with the remainder. So I'm going to take 32 times 7. That's 224, so it's a remainder of 1. So it is 7 and 1/32. So is this inches squared. Inches squared. And these are also inches squared. This one's inches squared. I can't fit it in there. There it is. Okay, so C, calculate the area of each face, record the values inside the corresponding rectangles. There they are. D says, how did we compute the surface area of the solid figures in previous lessons? We found the area of each side and added them up. Okay, so the computation would be 3 and 33 over 64 plus 7 and 1/32 plus 3 and 33 64ths plus 7 and 1/32 plus 1 and 97 over 128 plus 1 and 97 over 128. And I'm just going to put parentheses around all of this. I'm going to put inches squared on the outside so I don't have to write it over and over and over. So we have 1, 2, 3, 4, 5, 6 sides that we add up. So the surface area of this solid figure in this lesson is the sum of all of these. And I will calculate that and let you know what that is in a moment. Okay, so that added up to 24 and 39/64 inches squared. Okay, E says write an expression to show how we can calculate the surface area of the given figure. Okay, actually that is the expression. The how is the explanation. So I'll just bring this all down here. There. Okay, and then F says, what does each part of the expression represent? Okay, each part of the expression represents an area of one face of the given figure. We were able to write a more compacted form because there are 3 points, pairs of 2 faces that are identical. So what I could have done was said 2 times 33 and 33/64 plus 2 times 7 and 1/32 plus 2 times 1 and 97 1/28. We could have written it that way as well. So it says, what is the surface area of the figure? Okay, the answer to that is right here. So I'll just bring that down here because that problem did not ask for the answers. It asked for the expression. Write an expression. Okay, so I should focus on that. It says expression. This is an expression. This is what it's equal to. Okay, example 1. For the net used in the opening exercise to make a rectangular prism, Have the two faces with the largest area be the bases of the prism. Fill in the first row of the table below. So do that. Come back, check your answer, and we'll carry on from there. Okay, so here is the first row of the table filled in below. Now it says to examine the rectangular prism below and complete the table. So the area, we're looking for all the areas on this. Okay, so I need to find the area of the front. Area of the top first. Let's do the top first. That's this up here. Well, I know it is 15 centimeters, and it is 6 centimeters this way. So the area of the top is right here, top. Area equals base times height. Area equals 15 centimeters times the height, which is 6 centimeters. So the area is 6 times 5 is 30, carry the 3, 6 times 1 is 6, plus 3 is 9, 90 centimeters squared. So the area of top, or the base, is 90 centimeters squared. The area of the bottom would be down here, which is equivalent to the top piece. You can't see it in this diagram, but that would also be 90 centimeters squared. The area of the front is this face here. It's got a height of 8 and a base of 15. So I will do that in green. So I'd say area equals base times height. So the area equals 15 centimeters times the height, which is 8 centimeters. 8 times 5 is 40, carry the 4. 8 times 1 is 8, plus 4 is 12, 120 centimeters squared. So the front is 120 centimeters squared. The back is the same, 120 centimeters squared. The area of the left side and the right side are the same. That would be this rectangular area here with a base of 6 and a height of 8. So I'll do that over here. I'd say area equals base times height. Area equals 6 centimeters times 8 centimeters. So the area is 48 centimeters squared. So this is 48 centimeters squared, and this is 48 centimeters squared. Okay, so they didn't really explain really well what they wanted us to do here. I was wondering why did they give us 3 rows when all I had to do is write this here. Well, what they want is what is the actual area of the top, and it is 15 centimeters by 6 centimeters, and that's what you should write first, but I'll put it here. And this would be 15 centimeters by 6 centimeters. And then we want to say what those are. And those are the length times the width. So I'll put length times width. On this one here, in order to get the 120, I took 15 centimeters times 8 centimeters. And 15 centimeters and the 8 centimeters would be the length. Length is 15. And 8 is the height, so length times height. So this is also 15 centimeters times 8 centimeters. And this is also length times height. Okay. And then finally, area of the left side. Well, that would be the 6 times 8, or the 8 centimeters by 6 centimeters. 8 cm times 6 cm, 8 cm times 6 cm. So the height has already been called 8. So that's height. So I'm going to call this height times width. Height times width. I usually write width times height, but that's fine. I'm just keeping this in line. So my 15 is my length, my 15 is my length, 15 length, 15 length, and then W is 6, W is 6, they all match up, and then 8 centimeters is my height, 8 centimeters is my height. So this is what they were looking for in the table. What we multiplied to get this number, and what we were actually multiplying. Okay, example 2. We have this rectangular prism here. Here they were supposed to work with each other in class and calculate the surface area of the given rectangular prism. So I will do that real quickly, pause the video, try it on your own, and come back and I will see, and we'll check to see if you got the right answer. Okay, so here are my calculations. I did red, front and back, so that'd be this face here is the front and back that we can't see on the other side over here. The top and bottom is the green I did was this top, and the bottom that we can't see. They're equal, so there's 2 of them. And the left and the right are 45 centimeters squared each. Now this is just one, and I'm just saying up top that their front and back are equal. So now we want to come up with an expression. So I'm going to say the surface area equals 2 length times width, or length times height, I guess in this case. Length times height plus 2. And now if I do the top, that's length times width plus 2 times the width times height. Okay, so my surface area equals 2 times what I've already gotten here. 180. Length times height, 20 times 9 is 180 centimeters squared plus 2 times my 100 centimeters squared plus 2 times my 45 centimeters squared. Okay, so my surface area is 2 times 180 is 360 centimeters squared plus 2 times 100 centimeters squared plus 2 times 45 centimeters squared. So the surface area is 360 plus 200 is 560 plus 90 is 650 centimeters squared. That is my total surface area. Okay, so now it's exercises 1, 2, 3. We're going to do this a few more times. Calculate the surface area of each rectangular prism below. So I'm going to just start with the formula. The surface area equals 2 times the length times the height. I'm doing the face first. Length times height plus 2 times. Now if I do the top, it's length times width plus 2 times the side, which is width times height. Now I'm going to substitute in the values. The length is 12 inches. The height is 3 inches. Plus 2 times the length, which is 12 inches, times the width, which is 2 inches, plus 2 times the width, which is 2 inches, times the height, which is 3 inches. So this is the front back, this is the top bottom, and this is the left right. So the total surface area is 2 times 12 times 3, 36 inches squared, plus 2 times 12 times 2, which is 24 inches squared, plus 2 times 2 times 3, which is 6 inches squared. So the surface area is 72 inches squared for the front and back, plus 48 inches squared for the top and bottom, plus 12 inches squared for the left and right. So the surface area is 72 plus 48 plus 12. So 2 plus 8 is 10, plus 2 is 12. Carry the 1. 7 plus 1 is 8, plus 4 is 12, plus 1 is 15. So it's 152 inches squared. It's calculated there. 2 plus 8 is 10, plus 2 is 12. That's correct. Carry the 1. 7 plus 1 is 8, plus 4 is 12, plus 1 is 13. Not 152, but 132. Okay, 132 inches. Okay, on this one I'm going to color code it. So this red I will use for the top and bottom. Green I will use for the right and left. And blue I will use for the front and back. Okay, so the surface area equals, I'll do the front and back first, 2 times length times height plus top bottom 2 times, this is length and this is width, plus 2 times the right and left, which are width times height. Now I will calculate these. So I say surface area equals, substitute in my givens, my length is 8 meters times my height, which is 22 meters, plus 2 times my length again is 8 meters, times my width, which is 6 meters, plus 2 times my width, which is 6 meters, times my height, which is 22 meters. So my surface area equals 2 times 8 times 2 is 16, carry the 1, 8 times 2 is 16, plus 1 is 17, 176 meters squared, plus 2 times 6 times 8 is 48 meters squared, plus 2 times 6 times 22, 6 times 2 is 12, carry a 1, 6 times 2 is 12, plus that 1 is 13 meters squared. Now I'm going to multiply, so my surface area equals 2 times 176, 6 times 2 is 12, carry a 1, 2 times 7 is 14, plus 1 is 15, 2 times 1 is 2, plus 1 is 352 meters squared. That is just the front and the back, plus my top and bottom will be 96 meters squared, 2 times 48, plus 2 times 132 is 264 meters squared. So finally, my surface area total is going to be 2 plus 6 is 8, plus 4 is 12, carry a 1. 5 plus 1 is 6, 9 plus 6 is 15, 15 plus 6 is 21, carry a 2. 2 plus 3 is 5, no hundreds position, so it's still 5, plus 2 is 712 meters squared. Okay, on to C. I'm going to do the same process. Surface area equals, I'll use the same colors, 2 length times height, plus 2 length times width, plus 2 width times height. Substitute in my givens. The length is 29 feet. The height is 23 feet. Plus 2 times the length, which is 29 feet, times the width is 16 feet, plus 2 times the width, which is 16 feet, times the height, which was 23 feet. Okay, width 16, height 23, height 23, length 29, length 29. Just double checking all my numbers. And now I'm going to calculate. The surface area equals, now I do my simplifying. 29 times 23, getting some big numbers here. 29 times 23 is 667 feet squared, plus 2 times 29 times 16 is 464 feet squared, plus 2 times 16 times 23 is 368 feet squared. Now I do my multiplication by 2. And 2 times 7 is 14, carry a 1, 6 times 2 is 12, plus 1 is 13, 6 times 2 is 12, 13, 1,334 feet squared are my front and my back, plus 4 times 2 is 8, 2 times 6 is 12, 2 times 4 is 8, plus that 1 is 928 feet squared, plus 2 times 8 is 16, 6 times 2 is 12, 13, 3 times 2 is 6, 7 with those carried ones, feet squared. And finally, I come up with my solution. 4 plus 8 is 12, plus 6 is 18, carry the 1, 4 plus 2 is 6, plus 3 is 9, and 3 plus 9 is 12, plus 7 is 19. Carry the 1, and 1 and 1 is 2,998 feet squared. And that is the surface area of this very large cube. Okay, one more, 2 more. Okay, surface area, surface area, surface area. Let's keep going. So, SA equals 2 times the length times the height plus 2 times the length times the width plus 2 times, oops, change my colors, 2 times the width times the height. So my surface area is 2 times the length is 4 centimeters. The height is 2.8 centimeters. Plus 2 times the length of 4 centimeters times the width of 1.2 centimeters plus 2 times the width, which is 1.2 centimeters, times the height, which is 2.8 centimeters. Okay. The surface area equals 2 times 4 times 8. 8 times 4 is 32. Carry a 3. 4 times 2 is 8. Plus 3 is 11. 1 decimal place. So that's 11.2 centimeters squared. Plus 4 times 12 is 48. 1 decimal place is 4.8 centimeters squared. That's times 2 still. Plus 2 times 1.2 times 2.8. 1.2 times 2.8. is 3.36 centimeters squared. Surface area equals, now I multiply by my 2's, and that'll be 22.4 centimeters squared plus 2 times 4.8 is 9.6 centimeters squared plus 2 times 336, 6 times 2 is 12, carry the 1, 3 times 2 is 6, plus that 1 is 7, and 2 times 3 is 6. Our 2 decimal places, centimeters squared. And finally, the surface area equals, do my decimal places first. This is a tenth, hundredth. So I do have a 2 in the hundredths, centimeters squared. Now I'm doing tenths. 4 plus 6 is 10, plus 7 is 17. Carry a 1. The 1's position is 3, plus 9 is 12, plus 6 is 18. Carry the 1. I only have one tens place, and that's the 1 and the 2, which comes out to be 38.72 centimeters squared. Okay, in this situation, we have a cube. It is an area of a cube, not a rectangular prism. It is still a rectangular prism, but more specifically, it is a cube, which means this is 5 inches, and this is 5 inches, and this is 5 inches, and this is 5 inches. So they're all the same area. So rather than do the surface area equals length times width times 2 plus length times height times 2 plus width times height times 2. All of these are the same. So I'm just going to find the area of one side and multiply it by 6. So I'm going to show you a shortcut. So 6 times the base times the height is what I'm going to use for the surface area of this cube. So the surface area is going to equal 6 times the base, 5 inches, times the height of 5 inches. So the surface area is 6 times 25 inches squared. And the surface area therefore equals 150 square inches. Okay, a lot less work when you realize it is a cube. Number 3. All the edges of a cube have the same length. Tony claims that the formula SA equals 6S squared, where S is the length of each side of the cube, can be used to calculate the surface area of the cube. Use the dimensions from the cube in problem 2 to determine if his solution is correct. So let's keep this in sight. So he's saying that SA can equal 6S squared. SA equals 6 times 5 squared. SA equals 6. Remember, PEMDAS says to do exponential first. That's what the E means. Do the exponent first. 6 times 5 squared. And therefore, the surface area equals 6 times 25, or 150 inches squared. So, is he correct? I would say yes, he is. Why does this formula work for cubes? Because, as I said in problem number 2, all sides are the same. There are 6 of them. All we have to do is the area of one rectangle multiplied by 6. Okay? So let me bring that reasoning in. Okay, so why does this formula work for cubes? Each face is a square. And to find the area of a square, you multiply the side lengths together. However, since the side lengths are the same, you can just square the side lengths. Also, a cube has 6 identical faces. So after calculating the area of one face, we can just multiply this area by 6 to determine the total surface area of the cube. Now part C says, Becca does not want to try to remember 2 formulas for surface area. So she's only going to remember the formula for a cube. Is this a good idea? Why or why not? Okay, this is not a good idea. Becca's idea is not a good idea. Yes, there is less work, but you won't get the right answer if it's a rectangular prism. So the surface area formula for cubes only works for cubes because rectangular prisms do not have 6 identical faces. Therefore, Becca also needs to know the surface area formula for rectangular prisms. Now, if you only want to memorize one formula, then memorize the rectangular prism formula, because it would work for a cube as well. And that is the end of lesson 18. Go to your problem set. And oh, by the way, smash the like.